Good day, everyone. I'm Robert Wainscott, lead designer and co-owner, along with Eric Rossi, of Black Box Analog Design. Of course, not sure why I'm talking about that today, because I'm not really doing a black box product. What I am doing is I've looked around my shop here, and I can see that I have prototype parts and things sitting around, and I want to build something. I'm probably going to do a preamp, probably going to build a preamp, but it's definitely going to be something rather unique and interesting, and I might as well bring you guys along for the ride. A lot of my prototyping, because I'm working with vacuum tube gear, I do a lot of that, just on copper clad board, and I can solder parts to it and add pots and make things variable and do what I need to do. Of course, I couldn't put this in a real design, but these are great for prototyping. But I probably got a dozen of these things laying around, and it seems silly to not just put it in something that I can use personally. So the first thing I did is I found one of these copper clad boards. I removed all of its parts. The board had an awful lot of tarnish on it, so I boiled it in a water, vinegar, salt solution, and then neutralized it with some baking soda and stuff like that, just to get a lot of that corrosion off. I'll probably have to replace these tube sockets. But the purpose is I'm going to try to use this in some sort of preamp design. I believe I'm going to try to have two completely different sort of gain stages. The preamp can be two entirely different preamps based on this. That should be a lot of fun. Gosh, when I say that I have buckets of things here, I'm really not kidding. Buckets of vacuum tubes. Here's a bucket of input transformers, all kinds of input transformers from various companies, probably mostly Cinemag. I definitely like to use Cinemag when I do my my prototyping and put their products, their transformers can also be found in my first line of mic pre, and before I began manufacturing my own, the first runs of HD2s had Cinemag transformers. They're a great company. I absolutely love what they do, but I've got buckets of this stuff. And power supplies and power supply, transformers. So it's really going to be fun to just sit down and build something unique. So thanks for coming along. All right, everybody, here is where I am at so far. So I spray painted the old sockets because they were a little bit pitted, but I did put new tube holders in there, and I've got my copper somewhat cleaned up. I'll continue polishing that, and I've kind of figured out what it is I want to do. So let's take a look at that. Here's what I think is going to happen. You're going to have a microphone input and a DI input that comes right after the microphone input. That'll be some kind of transformer. Then you're going to have the mic in. After that, the DI, which would break that connection if you want. There will be a switch immediately, and then you're going to have two choices in this preamp. The first one's going to be a pentode gain stage, a very aggressive pentode gain stage, followed by a cathode follower. I'm going to use an AV7 for that. On the other side of things, you've got the switch, like I said. I'm going to use an AT7, then into another AT7, since triodes have amplifiers on both sides, followed by a solid-state cathode follower. Over here, I'm going to have The AV7 is a cathode follower. Over here I'm going to have a solid state cathode follower. That goes then to a switch and a 3-to-1 output transformer, probably a half nickel, half steel output transformer. So to recap, I've got my little circuit board that I've scrubbed and will continue to scrub here. I got what I believe is going to work. I've got vacuum tubes sitting around. As a matter of fact, I've got vacuum tubes everywhere, buckets of them. So pretty exciting stuff, and that's where we're going to leave it for right now. I believe that this old case could be really useful. It's got some rust on it, but I can probably sand that off. I can use this input jack. Maybe I can use parts of the power supply. I'm just going to strip this out and sand it down and repaint it. And that should give me a 2-space case with my cat as a helper. Cats like to help. Anybody working on electronics, if you don't have a cat with lots of small parts and things laying around everywhere to amuse your cat, then you know what? You're just not doing it right. You probably need to look for another line of work. So you got to have a cat to make it work. That's right, right up on the desk. That's where we go when we have stuff to do. So I have found a faceplate that I want to use. It's an older prototype faceplate. I can use those original switches, I just have to bore those holes out a little bit. Perhaps I will Eddie Van Halen this faceplate or pinstripe it up, who knows what. But I've got me a faceplate, now I just need to make it fit. Okay, ladies and gentlemen, here is where we are. I had to cut some extra holes, or I should say drill out some extra holes, widen some stuff up. But I do have a faceplate that'll fit on this. I've currently got this power supply kind of wrapped up so I don't get any gunk on it. Placing things inside the box. I'm going to have to go in here and Dremel out these standoffs. I'm not going to need those. Still trying to figure out really how I'm going to make room for everything that needs to go inside this box. It should be rather interesting. As you can see, my desk is beginning to take on the look that it should have, which is a messy desk. That means I'm doing work and I'm getting stuff done. As you can see over here, past my 5150 Mesa amp, I got the cat in the playpen. What you doing, Mr. Kitty? Yeah, that's right. You can't come out when I'm working because you get into things. All right, guys, back to work. All right, we got a little touch-up spray paint to cover it all up like it never happened. Okay, everybody, soon it's going to be time to look for parts. As you can see, I am using a load line plotter by the Valve Wizard. If you don't have this, if you do this kind of stuff, this is a great little tool to have. I can plug in some values, look at what kind of gain I'm going to get. I can look at my load lines and stuff. So, you know, this particular vacuum tube, the AT7, the plate wants to pull about 10 milliamps. I'm real close to that. I sort of have the idle, so to speak, sitting there at 5 milliamps. Looks like I'm going to have a lot of swing, way under as far as temperature goes, which is that red curved line you see right there. And this thing, it does all different vacuum tubes, and there's the frequency response on the top purple line there. Little bit of a roll-off, which is fine, which I want under 20 hertz. Apart from that, pretty much razor flat. So now all I have to do is go see if I can find all those parts. Well, what's happening here is I need some relays. So I've got this circuit board that didn't quite work out right. This is a prototype, and I can just lay that over this solder pot, and these parts just pop right on out. That's a way to recycle some of these old parts. Well, actually, they've never really even been used, but you know, recycle these parts as opposed to just, you know, throwing this in the garbage. So I'm going to do that. I'll need both hands. All right, everybody, let's take a moment and review where we are. I have a spray painted case with an on-off switch, a power input module. I have the power toroidal. I have the ability to select some things. I have a 1 to 7 step-up input transformer. I took those relays that I'd pulled out of the old board and glued them to a little piece of copper, and I've built a phase selector, a pad, a way to route, phantom power, all that good stuff. I have the previous power supply. I've got a little trim pod here because there's a value I'm going to need to get the voltage I want, and it's just a little easier to do that. I have my output transformer. I have the vacuum tubes I'm planning to use. I have my LED to light the box. I've got my faceplate. I have my high pass filter in place. Of course, I have the DI, the XLR in and output, the on-off switch, and my copper circuit board. And so I'm really kind of getting close to assembly. I just need to dig out parts for the you know, just the resistor values and everything to match up what I did with the load line plotters, and then I can start assembling that, see if I can get it all in this box, and then put it to use. So I'm really looking forward to that. Alright, everybody, it's time to pick some values for the high pass filter. I've got 2 different circuits running, so I'm going to use a very simple program. Oh, by the way, I'm just showing you sort of my upstairs in my living room place where I get a little bit of work done here. I am using a program that's a Google program called Every Circuit. I would definitely recommend getting it if you have to do some really simple things. And I apologize for it being a little bit jittery, but that's just the way it is. Anyways, Every Circuit allows me to sort of pick values, and I can go over here, I can play with it in real time, I can see where you know, where the values sort of land themselves insofar as my high pass filter goes. Every Circuit's a neat little program. Let me erase this for just a second. I apologize for it being so wiggly, but I'd really like to show you this. And I have a whole catalog of we'll discard different circuits that I've made and things that I can test, and I really dig it. You can run your programs, you get an idea of what your waveforms can look like, what your you know, phase is going to look like, all kinds of fun stuff. If you're not familiar with it, it's $15 a year. Every Circuit. It's a really sort of fast way if you want to lay out some simple things and not have to mock it up in LT Spice. So I know what my values are for my high pass, my 5-position high pass filter, and I'm going to go downstairs and see if I can find those values. Again, I apologize for the jerky video. As you can see from my messy desk, I must be making some progress. Let's take a look at what this faceplate's gonna do and what we've wired up so far. So to start with, I've got a shorting DI, and what that means is when the input signal appears here, it automatically goes to there and goes about its business. If I plug in an instrument into this, it breaks this short, and then the instrument signal travels across. what I have here is, because I'm running two separate selectable pathways, and that's going to be selectable from this switch right here. What happens is it picks one of two sides of a volume pot that the signal can go through, and also picks two separate sets of high-pass filters that we can use. Those high-pass filters, because of the values they land on, had to be different. In pentode-only mode, the signal will come in, go through high-pass filters, then hit the pot. In triode mode, signal comes in, hits the pot, goes through the first gain stage, then goes through the high-pass filters. So that's where we're at. You can see the two separate relays that I just used some, what is it? I use gasket. I get these at the dollar store for $1. It'll make things stick really, really well. So I've got these relays, one's glued onto the back of the pot, and this relay controls an LED indicator. So the next thing to do is see, does this actually work? It makes a lot of sense to test things before going too far. And you, Mr. Cat, need to get off my stuff. Now I'm using my 2001 function generator. As a matter of fact, the only reason I use this particular one is because it says 2001. And it does a decent job as a function generator. So right now I can see my 100 Hertz sine wave coming through the pentode side. I put a little blue LED there for pentode. This response button is going to change. As you see now, the triode's on, and we've lost signal to that side because it's moved over there now. So the signal is moving. It both moves and changes the LED. I can see that my high pass filter is working just fine as well. So I can route between the two sets, or the two signal sets. I have an LED indicator that's working that lets me know that I've done this. Red for triode, blue for pentode. So that's working. Signal's routing where it's supposed to go. I'll have the other switches to control other aspects of the unit. I have filled in some of the spots that had extra holes in them, where I made extra holes with my trusty, again, dollar store gasket maker. You really probably wouldn't want to ever use that on your car, but it's perfect for gluing things in and doing it in such a way that it can kind of take some shock. A lot of times, a lot of your crazy glues or your epoxies, you hit something good and hard and it'll just snap off. This thing will take a beating. And there you have it. Here's where we're at so far on the faceplate. This brings us to the very first test. I've stuffed the circuit board per my instructions. Right now I'm just testing the pentode section of it, not the cathode follower. So I've taken a function generator, and it comes down and feeds a little volume pot, just like the load I plan to put on the actual circuit. And from there we are feeding into the pentode, and I'm running at about probably a gain of about 110. I haven't quite tested that yet, but I believe that's what's going on. I'm feeding the plate 250 volts, and a 200 milliamp input right now gets me a 40 volt output, and that's pretty good. I do have a couple little things I can test. I've put this pot in place of the screen resistor because I want to look for an optimal value, but so far, so good. The test is showing what I believed it was gonna show me. So here we are. We're at the second stage. Oh, by the way, as my sort of star ground, I'm just using this piece of copper, so everything sort of ends up back over here, just like it would in the real world when I'm done with this. So right now, 200 millivolts can get me a 40 volt output on the pentode side. That's great. Because I'm using a 1-to-7 step-up transformer, I expect signals, you know, coming in at, I mean, I could see signals at almost half a volt. So I'm going to have a lot of room and gain for days. So next is to see how well the cathode follower handles it, and that's what's coming next. This catastrophe is what it looks like with the cathode follower wired up. I wanted a value. I wanted to see where the cathode follower would clip voltage-wise. I'm using a vacuum tube that it's not really easy to find values for because the triode is an AV7, which is really like a television mixer tube. It's an unusual vacuum tube. You know, getting fat cathode follower sort of load lines for that particular tube is a little bit of guesswork. So that pot allows me to dial that in. You can see right here that with the cathode follower, and I've got a 10K load on it, so it's loaded down pretty good. And I can get about 32 volts output now. And you can see if I increase the gain, where it begins to asymmetrically clip. Cathode followers will clip one side before clipping the other. So that's about where I'm at. It's looking like I can get about 32 volts out of the system. That means with the 3-to-1 output transformer, I can expect to get about 10 volts out of the transformer. So I need to do a little bit of math and see what 10 volts into my system looks like, and we'll take that from there. So, are you going to help me? No? I'm on my own this time? Fair enough. So here we are on my own. You can see I've got some square waves running through my function generator. I have gone ahead and wired up the second section of this with the AT7 tube. So it's an AT7, then feeding the other side of the AT7. Remember, triode vacuum tubes, like a 12AX7. It actually has two amplification stages in it. There are sort of, you know, two gain stages within the tube. So I have that wired up, and I have that feeding a little MOSFET cathode follower. You can see my little MOSFET chip right there, and then the blocking capacitor. I really like it. I like the way this thing saturates. I also like, because it's solid state, you probably can't see it very well, but there's an ever so slight overshoot on the initial transient, and I'm pretty sure that's the MOSFET itself, you know, basically stabilizing itself when input comes in. Now have a look at this. The MOSFET, right now I'm getting about 31, 32 volts out of this, which will go to a 3-to-1 reduction transformer. But look how this little guy saturates. Let me knock this back a little bit when I start to hit it. You know, that's a really nice looking saturation. It is a bit asymmetrical. As you can see, it saturates a little more on the bottom swing than the upswing. But I'm really impressed with how how that's going to handle loud volume. So I won't really clip anything, just as things get louder, I'll get some saturation. So here's where we're at. Now it's really time to put the whole thing together in the box. Also, I can see from this that I'm using maybe 16 milliamps on my plate, and I am using, I don't know, probably 300 milliamps on the cathode. So power-wise, I think I'm pretty good, and this is where we're at. Now it's time to put it all together in a box. And we've returned. You can hear the freeway in the background there, of course. I have a little box to hide my LED light so we don't go blind. And I'd like to bring up something. I was having a beer with a buddy, and he was telling me, he said, I don't understand why you do these things, why you show people what what it is you're doing. No one wants to see how the sausage is made. It's not interesting. It's not, it's not work you really ought to be proud of, because it's not all on a circuit board, and it all doesn't look super clean like you bought it out of a store. And the reality is that's really not why I'm doing this. I'm testing some ideas, and really B, the circuit's kind of easy. Circuits are circuits, but it's sort of the problem solving and what you have to go through. For example, you're like, hey, I wonder if something works. Well, how do I test that? What do I need? For example, I want the ability to adjust impedance so I can drive, ribbon microphones, for example. Well, crap, what do I need to do that? Well, hidden back there, I need an input transformer, with a tap on the secondaries to change impedance. Well, how am I going to change that impedance? It's just wires sticking out. Well, I'm going to need some kind of a relay to do that. Well, what does that relay want? Well, that relay wants 12 volts of power. Well, I'm going to have to build a power supply that has 12 volts of power in it. Wonderful. And how do I choose all that? How do I choose between those two wires coming out of the secondaries on that transformer? Well, I'm going to need a switch. And how do I know if that switch is on? I don't know. I'm probably going to have to put some LEDs in it so I know if I've selected it or not. Okay, cool. I'm going to have to run, 12 volts to that. And this thing's going to have power and a ground and all that fun stuff. So just for one thing, hey, I want variable impedance. Well, for variable impedance, I need an input transformer that'll do that. I need some sort of device that'll let me choose between an A and a B. This one's powered. I need then, since it's powered, I'm going to need power to run it. So I'm going to have to design that in the power supply. I'm going to need a toroidal that'll give me a secondary that I can create that kind of power with. I'm going to need some kind of a switch. That switch, so I know what I'm doing, I'm probably going to want to illuminate it. And that's a real problem. Then the next question is, well, how do I test that? How do I know if that works? Well, for the time being, I have just a little tabletop 12-volt power supply that I can wire into this. I can generate a signal. I can feed it now into the back of this box. I have an oscilloscope that tells me what's going on, so I can see, does that pad work? Yes, there it is, it works. If I really want to drive a ribbon microphone, does that work? Yes, it does. Is my phase working? This thing locks fast, but I can see, from the quick jump that, yeah, my phase is working. For the time being, is phantom power working? I'm not feeding it phantom, but I can hear the relay clicking. So this is where we're at right now. We have a completed circuit board, a completed power supply, a wired up faceplate. I've wired up the input so that the things I would like to have happen at the moment, which is a pad, an impedance selector, phantom power, and phase, that those things are wired up and that I can see lights when they're on. And that's sort of the way you know, we do this. It doesn't always look pretty. When it's done, it'll look pretty. I mean, I did take some time to zip tie these wires up, and once everything gets into place, it'll look a little bit neater. But when you build by hand that way, it is the way things are going to turn out. I don't see that as turning people off by showing them how the sausage made. To me, it's just solving problems. You know, how do we solve these problems? How do we make this device do what it is that we want it to do? So now it's time to drop in the main circuit board and then wire in the faceplate. So let's get to it. We are progressing along just fine. Let's have a look at where we're at. We have our output transformer bolted in with, what are those, aircraft bolts. They're locking bolts. That's nice. That's not going to go anywhere. And we started wiring up the faceplate into the unit. There's still some things that I have to do. I've gathered up. These are all dirty grounds from the faceplate, meaning grounds that are coming from either a relay or an LED. I keep those separate from power. The faceplate does have its official 12 volts now, so that things can be routed along. You can see where we glued our MOSFET circuit board to our copper piece here. And really we're just sort of at the end now, where you see all the labeled cables, and this all has to go either to the faceplate or, yeah, pretty much all that's going to the faceplate at this point. I think 2 of these wires go to the output transformer, but these are all faceplate items that'll go in. I'm not really super sure how I want to mount this yet. It doesn't have a lot of weight to it, and I'm probably going to need to be able to lift it up a little bit if I ever want to remove these vacuum tubes. So quite frankly, I'm thinking I'm just going to Velcro that in. So we're coming up to the home stretch. You know, we still have some grounds to run. I haven't counted my ground runs yet. I think I have something like 17 of them in this box. 17 ground runs. So this is where we are, and you can see it's coming along fairly nicely. All right, so I just fired it up for the very first time as a completed circuit, and I'm happy to say, other than one minor tweak that I need to do to the power supply, which is the adjustment that I spoke about earlier. I have my 250 volts, and I just need to measure the resistance on that pot, and then drop a resistor there, and I'll be done. And I'm very pleased. You can see that my impedance switch works. Look at that. Look at that saturation, or that completely different top and bottom. This is my pentode circuit. You can, sorry, I have a little piece of copper at the moment, so that we're not blinded by the light. I'm going to have to work. I need to light the light up, but I don't need to light this area up. Really, there's nothing there. I might take a very large vacuum tube and just, you know, some old thing, and just epoxy it to the front, so when it looks like that light's coming through a big old vacuum tube, I'll look around. I bet I got a couple nice old vacuum tubes I can just epoxy to the front of that. But you can see my pad works, my impedance works. I can change my response. Right now I'm in pentode. I can move that over to triode, and I get a completely different type of saturation there. That's kind of interesting. A lot of gain. And this is a two-stage deal, so depends on what part of it I want to sort of saturate. But I'm real pleased with how that turned out. So I have the two different responses. One's a pentode into an AV7 cathode follower. One is two AT7s. One to sort of bring up the microphone volume, and then of course another to boost that. And that's into a MOSFET cathode follower. So I have my two stages, and then a MOSFET follower into the output. So I don't know, I'll probably do some slow pans around the box, and for the rest of it I'll be talking to you through probably through some microphone plugged into this. And I've got to tell you, this has been an awful lot of fun.
Yes, it has been an awful lot of fun, and right now I'm talking to you through the preamp. I am talking to you on the pentode side of things using a blue baby bottle. And the reason I chose that microphone is because it's not, it's not cheap per se, but it's not an expensive microphone. And check this out. As you can see, as I drive the pentode harder and harder and harder, it just kind of begins to saturate a little bit and get beefy, 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 beefy. Tell you what, let's listen to a little bit of guitar and bass. You'll hear where I switch between pentode and triode on that, and then we'll come back and I'll talk to you on the triode side of things. There you have it, a little bit of DI on the guitar and bass. And I purposely took the treble out of the bass so we could really just focus on the low end. By the way, I'm talking to you as we fly around here. On the triode side of things, I have the impedance selection chosen at the moment, and I'm kind of driving it a little bit hard. I can drive it harder. I can really sort of bring some balls into this. So that's the triode side of things. We heard the pentode side of things. I can take this impedance off, and that cleans that up a little bit as well. I can really tell you this has just been an incredible amount of fun as we fly around over things. Let's switch back to the pentode side for grins. We are back on the pentode side of the street. We didn't check that with some impedance. Let's click that in for fun. A little bit of changing some impedance for the pentode side of the street. Guys, thank you very much if you've made it this far, and we'll catch you next time.